So hello everyone, hope you are doing good and welcome back to my channel. Today we are at day 4th of the June daily Leetcode challenge and we again have a medium level question in front of us. It's question number 547, number of provinces. So if you would remember correctly, from the last 2 or 3 days, we are getting questions which are related to either trees or graphs. So ultimately, we are doing either BFS or DFS. But for today's question, there are some more ways to do it. We'll discuss that today. But ultimately, we'll be solving this in the more basic approaches only using the BFS and DFS. So coming to today's question, it's question number 547, number of provinces. So as you can see from the question itself, it is related to something called a province. We'll see what is the definition of that, and ultimately we have to find the number of such provinces. Okay. So what they've given is first of all, see the way they've given the input. Okay. So after reading the question, we'll get to know that it's like a adjacency list. Okay. This is the name given to it, and it's like adjacency list. What is adjacency list? It basically means that it's a way of telling us which node is connected to which other nodes. Okay, for example, this is for the zeroth index. Okay, so this will tell zeroth index is connected to which all nodes. Okay, similarly this is for the first index, this is for the second index. Okay, there are different ways of saying it. In this case, they are calling it not from the zero to index, but they're using the first index. Okay, 1, 2, and 3. So basically, this is for the first node. Okay, that means first node is connected to itself. That you can call it a self loop. First node is connected to second node, as you can see. Node 1 is connected to node 2, and node 1 and node 3 are not connected. Similarly, this is for the second node. Okay, it tells that second node is connected to first node. Okay, you can see here second node is connected to first node. Second node is connected to itself. It's kind of a self loop, which is not shown in the diagram, and second node is not connected to third node. Okay, and when it comes to third node, this is for the third node. It's not connected to first and second node. And when it comes to third node, you can say a self loop exists. Self loops are not mentioned here. So it's their way of giving it. Okay, it's basically called adjacency list. And one thing you would have noted is that they are, for example, is for the first node. For the first node, the first index, it's always one. Similarly, the second node, second index one. Third node, third index is one. What it means is they are indicating a self loop. For each node, we are getting a kind of self loop. This is the same thing which you can see from this example. Here, none of the nodes are connected, but you will see that self loops are indicated through one. Okay, so this is something which we have to be careful about while coding. We have to address this issue also, that case of self loop. Okay, so now coming to the question in terms of the way they've given it. So there are entities. Okay. Uh, See, entities means that sense list will be a n square cross n, sorry, n cross n. That is a n square one. Okay, n cross n, because for each node we will try to find its whether it's connected or not to all the other n nodes. Okay, including itself. That is the basic idea. There are n cities. Some of them are connected while some are not. If city A is connected to B, the idea is C. If A is connected to B and B is connected to C, that means A and C are indirectly connected. Okay, please remember this point. A is connected to B, B is connected to C. That means A and C are indirectly connected, and that's how they are dividing a province. Okay, a province is a group of directly or indirectly connected cities, and no other cities outside the group. Okay, so either all the nodes are connected directly or indirectly, they form a province. Okay, for example, in this example one, you can see 1 and 2 are connected, so they form a province. Similarly, 3 forms a province. Okay, they have see here they're defining how the input is being read. We are given n cross n matrix called is connected, where is connected of ij is equal to 1 if ith city is connected to the jth city directly. Okay, and if its value is 0, that means they are not connected. Okay, that is the basic idea. The demand of the question is we have to return the total number of provinces. Coming to example 1, you can clearly see 1 and 2 are connected directly. There are no indirect edges here. So a total number of ones will be, see, this whole will be one province, including 1 and 2, and 3 will form a separate province. So the answer is 2 here. Okay. Coming to the second example, here there are no edges. Okay, so each node is a province in itself. So there are total 3 provinces. See, there are many ways to do it, but remember this constraint around it's around 200. So we can also try for n square approach, and even somewhat more than that. Okay, it will pass. So see, there are many ways to do it. First thing is it's a basic traversal, right? As you can see, they are talking about direct or indirect connected edges. Okay, how to find that? We can either do a BFS or a DFS traversal. That is the general way of doing it. If you are more, used to lead code, you will know that there is a data structure called disjoint set union. Okay, there is a data structure called disjoint set union. Lead code calls it as a data structure, but in other, if you see in Wikipedia and all, they will call it as an algorithm. Okay, so there are many ways there are different ways of calling it. Okay, so disjoint set union will be a direct application of this question, because that is what the purpose of disjoint set union is. Because so what will happen is that I will just give you idea, but finally I will be implementing it using BFS only. Okay, So I will just give you an idea what is disjoint unit. If you get time, please go to the Leetcode cards and you will get to understand what it is. I will just give you some hints. See, each group is represented by a leader. Okay, each group is represented by a leader. What is that leader? For example, see in this case, two is connected to one, one is connected to. It's basically bi-directional lines. Okay, so one of them will become a leader. That is the basic idea. So each group will be represented by a leader. If for example, a group has a leader A and the other group is also having leader K, that means they are representing the same group. That is the basic idea. And if elements of the A group, like leader represented by A group, is connected to some other group, then they also will be part of that. So that is how you can get the number of provinces. Basically, I will not go in detail of that, but I will just give you a hint that there is something called disjoint union. Also, this could also be asked in your interviews. Okay. So coming to the way I am going to solve it, as you may be knowing, for the last 2 3 days I am using BFS approach because that is what is seems to be more suitable to me. You can also try DFS approach, but I will be solving it using BFS approach. Okay. So yeah, let me mention that here as well. So I will what I will be doing is, so yeah, it starts from here. Okay. Yeah. So I think the question should be clear to you. We have to find number of provinces. What is a province? It's a group of directly or indirectly connected edges. Okay. Indirectly connected nodes. Okay. So idea here is I will go through each and every node. Okay. If it is not already visited, I will be visiting them and starting a VFS from that node. If it is already visited by some other node or it's a part of the traversal of some other node, then I will not visit it again. Okay. So I think after I go through the code, you will be getting a better clarity on it. So n is basically the length of the is connector. That is from here, if you calculate the length, so that means any direction can take. Okay, it's a two-digit array, right? You can take L and sorry the length along each any of the directions. Okay, you'll get the n. This is the variable I'm declaring, and it's going to be the final answer also. Okay, so please pay attention to this. Initially, it is 0. I am creating a set. What is a set? Basically, set means it will be caching. It will be using the hashing approach to store the you know integer in this case. So this is easy for me to see the insertion and the checking whether it exists or not will take enough in time, right? That's why it's the best way to use it in this case, right? And if you have seen my previous solutions of for the last 2 3 days, whenever we talk of BFS, we will always have a set. Okay, so this is going to be the outer for loop. You can say it will be run for each of that. Okay, okay, each of the nodes. For the first node, let us say the zeroth node. Okay, what will happen is, see, I will check if the zeroth node is in overall visited or not. If it is not in overall visited, okay, I will be coming down. If it is there in visited, it will be like this list of the will be skipped. Okay, let us come the case where let us see is the first node. Okay, that means we are just starting in the on that process of running that. Okay, so what will happen is this will not be executed. Okay, it's not in this, so this will not be executed. We'll come to here. Okay, so what I will do is I will increment my provinces by 1. I will find that is I have found my first province. Okay, so I will start my BFS traversal from it. Okay, as you might be knowing, in all my solutions, this is how I've implemented it. There will be a queue where I is the see this particular I will be the first element of the queue. Okay, I will be adding I in this overall visited set. This is see initially it will check. If it's not existing only then it will come here, right? So basically when I'm doing this, it means it's not already there. That's why I'm adding it. Okay, till the queue is empty, I will be running this. Okay, I will be popping out the leftmost node of the queue and I will calling as a node. Okay, for j in range n. Okay, so what I'm checking is as you can see here. For the first node, this is the adjacency list or whichever you call it, right? So this is what I'm doing it. Each of these numbers will be representing j. Okay, so for j in range of n, okay, is connected node of j. That means for the current node, I am just checking which all nodes it's connected to. Okay, if j that means is connected node of till is connected node of j is equal to 1. J, see, this is to avoid self loop. Okay, this is to avoid self loop, and j, that is for example, see, in this case second node is connected to first node. Okay, second node is connected to first node, so that is what is j is. Okay, suppose I'm starting the before from the second node, it will tell me that I is a node which has s to it. Okay, so that is what is j here. So j will be 1 in this case and our node will be 2. Okay, where is the node here? It will be 2 in this case because I'm starting the previous from it, and j will be representing 1. Okay, this is to avoid self loop, and this is to check if this node is already existing in it or not. Okay, that is the basic idea. It will be added to queue, it will be added to the set. Okay, and similarly this thing will run till my queue is not empty. Finally, when the queue is empty, I will be coming back to this for loop. Okay, and this for loop will be executed. Remember one thing, let me show a quick trace of it. See, when I start this for this particular example one, what will happen is initially I will be one. Okay, I will be one. You can call it zero, whichever you call it, right? One zero, whichever we call it. So let us say zero, because in this case it's starting from zero index. Okay, so here basically one which you're seeing is it should be a zero, right? You can just imagine it as a zero, right? So initially this condition will fail. Okay, provinces will be incremented by one. This will be zero. Okay, so what will happen is self flow will be avoided. Okay, so directly it will come to one. J for this one will be accepted. So Q will be added with this particular index. Okay, it's connected node. Okay, in this case it will be one. Okay, and it will add to the overall visited node, overall visited set also. So when the for loop goes to the next turn, it will identify this. Okay, this will become true. Okay, this will become true because it's already, see, if BFS identifies a node, then the outer for loop it will not be executed again. Okay, that is the basic idea. That's why I'm using this. Okay, please understand the overall aim of the question. If a node is already visited, that should not be counted again, because we have to find ultimate number of provinces. Province means it's a collection of direct or indirect character edges. Okay, cities. So that is what why we are doing BFS, because we are trying to find out which all nodes are indirectly or directly connected to this particular node from which we are starting. If it's part of that, then it will form a province. Okay, that is what we are doing through DFS. So yeah, now coming to time and space complexity. See, this follow will take O of n time, and for each of each I, what we are doing is we are running another O of n for loop. Okay, so basically time complexity will be O of n square. Let me quickly write it here. It will be O of n square. Okay. Coming to space complexity, see, this is the only thing which is consuming some space complexity. But when the program ends, total number of rows inserted in will be n. Okay, so it's going to be around O of n. So see, it's going to be n square, and this is going to be O of n. Okay. So I will just again repeat the overall aim of this question. See why all these things. See, this outer follow will ensure that each node is visited. Okay, for example, in this case, you see these nodes are not connected at all. Okay, so each of them is going to form separate province. So what I will do is, from this I will start a BFS. It will not end anywhere. Okay, from this I will start a BFS. From this I will start a BFS. Okay, these will be some. See, obviously we are not going to get any nodes from the BFS, but we'll just start a BFS to ensure that the nodes are, if anything is connected to them, they are included. Okay, they don't form a separate province. Okay, so that's what the idea is. See, from will this follow ensures that we go through each of the nodes. Okay, because there can be a case that if a node is not connected to anything. Okay, so then also we should not ignore it. It should be forming a separate province. Okay, and this BFS ensures that whichever node is directly or indirectly connected to it, it is included in the same province as the ith node. That is the basic idea of it. Okay, and nodes which are not connected to anyone at all, they form a separate province. And for this follow ensures that we go through each of the nodes. So yeah, that was the idea. Time complexity of n square, space complexity of n. You can also solve it using DFS, and in the beginning of the question itself, I've given you the idea for the disjoint set union. If you get time, please go through that. That will be definitely beneficial to you. But you have to add a separate class for it, and there are some two functions for it. Okay, find function and the union function. You can just go through them. There is a separate explorer card in the Leetcode for that. Just go through it. It's definitely beneficial. There are many graph questions which with see, DFS BFS will always come, but there will be questions where we cannot solve it using DFS and BFS, and we have to go for the disjoint set union. So have an idea of it so that when such a question comes, you don't find it difficult. So yeah, friends, that was all for today. If you find us, please do comment below, and we can discuss it further. See you tomorrow. Thanks a lot.